Good afternoon, Robin. Good afternoon, everyone. Welcome to the third in the Professional Providence Society PPS series of 5 webinars with Professor Robin Wood of the University of Cape Town. I'm William Sanderson-Mayer, the Managing Editor of MedicalBrief, and I'll be facilitating this webinar in which the series is now pretty much 3 months on, and it's run almost as long as COVID has. So we're beginning to get a kind of longitudinal look, a much clearer picture of where we're going. Professor Wood will unpack the most recent research and developments around COVID, but it also affords an opportunity for practitioners to relate their own experiences and questions and comments that come from them. Professor Wood will speak for half an hour, and then we'll take questions, and we may well leave some questions in between. If you want to at this late stage, please feel free to use the chat function to add questions. We have a great number of questions already submitted. So just briefly to introduce Professor Wood, he's the head of the Desmond Tutu HIV Foundation, a member of UCT's Institute of Infectious Diseases and Molecular Medicine, an A-rated National Research Foundation Fellow, a visiting Fellow at Harvard, an honorary professor at the London School of Health and Tropical Medicine. He's served on numerous scientific advisory boards, including PEPFAR, the World Health Organization, and the International AIDS Society, as well on the International Partnership for Microbiocides, the TB Vaccine Initiative, and the Gates Foundation. But I think perhaps most interestingly, in connection with this evening's discussion around the transmission of COVID, he leads the scientific research group of the Medical Research Council of South Africa and UCT, their flagship program investigating the aerobiology of TB transmission. So, Robin, welcome. It's nice to be able to speak to you again. I think perhaps it's you can take a bow. I think the very, very first time we spoke, or at least more than once that we spoke, you postulated that exposure to animal coronaviruses gives some pre-existing immune protection, and that seems to be verified now.
Either very lucky or very insightful.
Surely insightful. Tell us about that research briefly.
I have a very close family member who is a veterinary surgeon in Australia, my son, and we often discuss the sort of compartmentalization of medicine and veterinary science and how they very rarely interrelate too much. So it was in those discussions with him about how common coronavirus was and how it presented in different animals that we came up with this sort of hypothesis. And we did a very quick rough and ready survey of veterinary surgeons to see if they seem to have a low infection rate for COVID, and it certainly seemed that way. It's not a rigorous study, but that's where the concept came into being. And also it sort of fits with, we basically live on this planet in a sea of other organisms, all of which are competing, and our immune system is competing with them all the time. So it seems unlikely that a family of viruses would suddenly jump up which had no relationship to any of the other members of the family. And if you look, I think there's 7 human coronaviruses, and 3 of them use the same spike protein and binding to ACE2 receptors. So again, if we just look at this within the spectrum of other things occurring rather than exceptionalism, it sort of feeds that sort of thought.
And Robin, the Nature study, that basically suggests, I don't know how strong a study it is, that the infection with beta coronaviruses induces a long-lasting T-cell immunity. Isn't that quite interesting, given that it's not clear that people who have had the coronavirus, whether their antibodies actually remain effective against reinfection.
So that was some work looking at patients who'd recovered from SARS-1, which was 13 years ago. And they had immune responses, quite vigorous ones, to SARS-CoV-2. And obviously that's separated in time by 13 years. So it suggests that certain types of immune memory cells can cross-react between certainly SARS-1 and SARS-2. And there was some earlier work which is puzzling from blood which had been taken many years ago, which certainly had antiviral activity when exposed to COVID. So it sort of fits in with this concept that there may be other epitopes besides just the spike protein. I think there's a series of proteins, but one of them is the ORF protein, which seemed to be the one that was involved in the Nature article. But I think it sort of fits in with a philosophy of multiplicity of organisms, each of which is reacting where our immune system is reacting to them, and they're trying to find little niches and their vulnerabilities. So it's an ongoing battle.
Let's go on then to today's discussion around transmission and the absence of data. Especially, perhaps you could kick off by, I get sometimes what I read, it seems to make, if you could make clear the distinction between airborne and aerosol infection, and what the issues are around that at the moment.
So if we look at the sort of world leader, which is on this, which is the WHO, and I was sent the South African infection control guidelines in April of this year, and I looked at them, and they essentially just quoted that there were only 2 known routes of transmission, and this was reference to the WHO. So there are two routes are: one, respiratory droplets produced via sneezing, coughing, which are then directly inhaled by person-to-person transmission. And I find that a bit difficult in that people don't cough and sneeze in other people's faces that often in order to drive an epidemic like this. And then their second one was via respiratory droplets that land on environmental surfaces, this so-called fomite transmission. And then they made a third statement that no airborne transmission has been recorded except during aerosol generating procedures in close proximity. And then they there was throwaway phrase that in an analysis of 75,465 COVID-19 cases in China, airborne transmission was not reported. So that sounded pretty impressive. But I did look, instead of the quotations of secondary references, I went back to the document which the WHO was referencing, the WHO, which, let me just see, I think it was, yeah, it was a situation report 66 from the 26th of March. And it's true that they did say those statements. And in all other contexts, available evidence indicates that COVID-19 is transmitted through close contact through respiratory droplets such as coughing and by fomites. So the quote was correct, but then they gave 7 references to justify this. So I looked up the 7 references, and the first 5 didn't actually mention the means of transmission. The 6th one was a quote of the WHO, of another WHO document, which was the WHO China study. They sent over WHO experts to China very early on in the epidemic, and that's where the large numbers are being quoted from. The only problem is that when I then checked with the Chinese CDC that was reported at the same time, they didn't actually say that it wasn't transmitted by aerosols. They raised the possibility and said that we don't know. And then the last reference was quite amazing. It was a reference by Ong et al., who was a chap who looked in Singapore hospital at 3 patients. And in fact, he found COVID RNA on the vent, the extraction vent of the room. He didn't find it in the air, so they're quite right there. But he did actually say that finding it on the exit vent did suggest that it was transmitted through the air by air currents to the vent, and then pointed out that his techniques for trying to isolate the virus were inadequate, and that that's probably why he didn't find it. So he actually came to really the opposite conclusion. So what it shows you is that when you have a hypothesis and you want data to fit it, normally people can manage in some way to stretch it to try and fit it. But to my mind, that was a misrepresentation of the references which they were quoting.
It's rather worrying that the organization which is quoted most authoritatively on what the situation is has now had to backtrack not only once on this, but several times on other positions it's taken. On the airborne discussion, not everyone, including yourself, is buying the World Health Organization position. Tell us about the challenges that have come towards this.
So yes, it's quite interesting. There was a preliminary report from the National Academies of Science, Engineering and Medicine, which was on April the 4th in the US. And this is a pretty impressive group of people. And they came to the conclusion that while the current SARS-CoV-2 specific research is limited, the results of available studies are consistent with aerosolization of virus from normal breathing. And I went through that in some detail, and they were very prescient. Many of the studies that they quoted were from their colleagues, which have been subsequently published. So it was quite an impressive, at that stage, they came out fairly firmly on that. Then later on, there was a paper by a scientist that I do hold in high respect, Lydia Marowska from Queensland, and she wrote a paper with a Chinese CDC scientist, and it was called Airborne Transmission of SARS-CoV-2, the World Should Face Reality. And interestingly, when I read that, I actually did send it to the Department of Health in this country, and that's when I questioned the guidelines which they had produced. But then everybody sort of ignored that, and it sort of went away. And then this lady scientist again coupled up with a top scientist from aerosol scientist from Johns Hopkins, and they wrote an open letter which was signed by 238 leaders in the world. And they came up with a statement that we appeal to the medical community and to the relevant national and international bodies to recognize the potential for airborne transmission of COVID-19. There is significant potential for inhalation exposure to viruses in microscopic respiratory droplets, microdroplets, at short to medium distances up to several meters or room scale. And we are advocating for the use of preventative measures to mitigate this route of airborne transmission. So what you're getting there is a growing swell of opinion from top leaders who are questioning the international guidelines at the moment.
And what has the response of the World Health Organization been, and where do the South African national guidelines stand at the moment?
Well, South African, having had this brought to their attention, have set up a special advisory group in order to see if they should change the guidelines. I am actually not really au fait with the inner workings of the WHO on this issue. but it does seem as though they are preparing the ground to backtrack a little bit. But they do seem as though they will, I'm guessing they will grudgingly allow this to be something that can be considered under exceptional circumstances, but they will probably justify their current stance. And it seems as though this is sort of confirmational bias type of things. They have not been very impressed with the data that's been coming out, and they've sort of poured a bit of scorn on it. But there is increasing amounts of data questioning and supporting this.
Robin, if the 238 scientists you were speaking of speak of a need for essentially different control measures. So one needs one set of control measures for large particle transmission. And obviously it would mean something different if you're looking at the seriousness of small particle transmission that hangs in the air for a long time.
Well, the problem that I think is, which allows this sort of debate to take place, is people use words such as small and large and aerosol and airborne. And it really comes down to being very careful on what you're defining as that. And then suddenly the WHO throws in this new sort of spanner in the works of, oh, what about aerosol generating procedures? So I'd like to come back to that at some stage or other. But let me just say what my work suggests. Well, let's go back a little bit. Let's go back a couple of years ago. Somebody did a very nice study of speech and took patients that spoke 4 different languages and got them to speak at, I think, about 8 different intensities, and measured the particles that came out whilst they were doing that. So this comes back to that first statement of the special group from the Academies of Science that normal breathing could be a cause. So what that study showed was that particles are produced in the periphery of the lung. Now, the periphery of the lung has no flow, but it opens and closes with each breath. And the surface area of the peripheral lung is always said to be, each lung is 1 tennis court for some reason. But anyway, it's a large area. And what happens there is, as these bellows open and close, they're covered in surfactant, which is a detergent which sort of allows the surface tension to be controlled. And that produces these droplets, which these people were measuring. And by far and away, the largest number of particles are in the range of 1 to 2 microns. Now, the reason why this is important is those are the ones that if someone else breathes them in, they will go straight down to the lungs and have a high chance of being retained in the periphery of the lung. Anyway, so this study that I'm referring to found particles only between 1 and 10 microns, that's millionths of a meter. But by far and away, whatever speech intensity you had, the major parts, major size was 1 micrometer. Now, what happens is every respiratory activity that you do, you produce these particles because they're actually produced during inspiration as you expand your peripheral lung. So essentially, if you cough, if you speak, if you just take deep breaths, you will produce these particles between 1 and 10 microns, most of which will be 1 micron in size, 1 to 2. And that's just normal breathing activity. On top of that, you can add other particles. So as you move up to the upper respiratory tract, then the speed of the air speeds up. And it would seem as though if you have loud singing, if you have language with P's and T's, you'll be producing larger particles from the mouth. So essentially, what we in the aerosol science believe is that small particles are produced by every respiratory activity. The only thing that a cough does is it increases the speed of those particles that come out. So we're very interested in the 1 to 2 micron particles because they're the ones that get into the lower lung. But let's see the larger ones, which here I think we're talking between 5 and 10 microns. And what happens is they come out of the exhaled air, out of the mouth, in a sort of cloud which has a high humidity. As that cloud dissipates, then each of those particles will lose some of its liquid as it moves into a drier atmosphere. So even those particles from 5 to 10 can in fact become 1 to 5. So the concept that normal activities of breathing don't produce potentially dangerous aerosols just doesn't fit with the data. Next question is, if the particles are being produced, are they being produced where the virus is? And COVID does cause a peripheral pneumonia, and therefore it would seem likely that particles produced in the periphery of the lung may have active virions in them. And then we can talk at some stage about all the subsequent data that's become available. And I just say that my own research is 100% fits with those size particles that I was talking about with that rather nice study of different types of speech. So if I get people to just breathe normally, to take coughs, or to take very deep breaths in and out, if I calculate the number of particles produced per minute, they're all much the same, because it's dependent on the amount of air that you breathe in.
Dr. Don O'Mahony from Port St. John says, he's basically saying, well, can there really be any doubt? And he cites an April JAMA study which confirms COVID transmission rates consistent with droplet and contact spread based on household attack rates and effective reproduction numbers. And he says when that is compared with airborne viral pathogens such as measles and chickenpox.
Yes, interesting idea. I do find comparisons between different diseases and their attack rates a little bit problematic, in that it really depends on the amount of virus that's being exhaled by someone and the infective dose that goes to somebody else. So I think measles and chickenpox, it seems as though the infectious dose is very small and the amount of exhalation of those particles is very high. And therefore it's sort of been linked to say, well, that's aerosol. So we've got to come back to the size again. What is an aerosol and what is airborne? But we do know that SARS-1 was able to be transmitted over relatively long distances. There's a study of the Amoy block of flats in Hong Kong, whereby an aerosol actually produced probably from the sewage system got into the air system and infected many, many people. There's also a study on an aeroplane whereby somebody with SARS-1 managed to infect people in the 4 seats in front of them, 2 seats behind, and some people on the other side of the plane, presumably carried by air currents. So SARS-1 certainly has a slightly different and probably lower reproductive number, but that is airborne. So this argument of particle sizes, large and small, is done very cavalierly. If we start off with the principle that every respiratory activity produces respirable particles which can potentially be breathed into the peripheral lung of somebody else, then that's really what I think the aerobiologists are trying to get us to consider. But I'm not sure that the RO number itself defines that. the WHO certainly separates those into aerosol and droplets. But again, I think we need to be very careful about what we're really referring to. Certainly, certain speech can produce large droplets, and sneezes certainly produce lots of very large particles, and they're so large that they can have ballistic characteristics because they have momentum. So a 50 micron particle in a sneeze can certainly go a long way, but that's not my conception of how this disease is transmitted.
So what are the consequences of aerosol transmission, and do you want to expand on that, on how you see it being transmitted in the air?
So I think if you look at the animal models, there's no doubt that if you put ferrets, who seem to be a model for COVID-19, if you put them in a cage, they will infect each other, and they get viral particles in their nasal secretions, in their urine and in their stools, but they don't get too sick from this disease. They get a little bit of lung disease, bronchiolitis. And somebody has looked at ferrets that are separated from those that cage, and certainly the disease was transmitted. Less efficiently, absolutely true, but was transmitted over a distance. So then we sort of, I think, need to think about the impact of distance. And distance obviously has a major dilution factor, because the distance, if you imagine a sphere around you which you're contaminating, that sphere size increases by the third power of the radius. So very quickly you get into, so I'm thinking at 4 meters, I think you've got tens of thousands of dilution. So again, if your infective dose is very small, distance is going to be very important. But there has been, let me just go through what I think is the sort of data to highlight this. There's epidemiological evidence for airborne transmission. So there's no doubt there's been a lot of cases of asymptomatic patients transmitting the disease. And that means they're not coughing and sneezing. So they have to be doing it by some other means. There's an interesting anecdote from Mongolia, where somebody in a house just walked past the open door on a regular basis as someone with COVID and got the disease. So it can transit. And then there's the Guangzhou Chinese restaurant story, whereby 3 families got infected whilst dining in this Chinese restaurant, and a rather elegant study was done of the air currents within this, and it seemed as though the ones that got infected were the ones that were downstream of an air supply from an air conditioning unit. There are super spreading events. There's the Shincheonje Church, whereby one super spreader infected 166 congregants in the church, and then a subsequent 4,400 people in Korea. There's another one which I was reading, also in Korea, from Zumba dancing. I didn't know what Zumba dancing was, but it looks rather energetic when I looked it up on the on YouTube. So apparently the instructor, it's a sort of physical activity thing, managed to infect everybody. More recently, we've had the choir practice with a very high hit rate of almost 90% of the choir got infected in Sanjit in Washington State. There's recently been a Chinese mall in Wenzhou. So there's lots of epidemiological evidence that transmission is taking place over certainly longer distances than just the close association that we've been told about. How important that is, we can debate. Certainly RNA, viral RNA, has been isolated from the air in hospitals. I think there's been a couple in Singapore, Wuhan, Changchun in Korea, and more recently in Nebraska, a very nice study that's just come out. So then the WHO said, well, that's all very well, but we haven't seen that the virus survives in air. So there's been two recent studies, one by Durham, and the problem they had there was that they had to produce the droplets, and I think they produced droplets less than 5 microns with virus in it. But in order to stop them settling, they put them in a drum which circulates. But they showed that the virus stayed alive for 3 hours, and that's been reproduced in another elegant study for 16 hours. So we know that the virus can stay there. But then when the WHO wrote a commentary on this, they said, oh, that's okay, but it's not really a natural situation, so we're not going to take any notice of that. Well, recently, there was a study in Nebraska, the study I was talking about, Santa Pia, actually did find live virus, which was able to infect cells in the air. So, you know, there was a lot of circumstantial evidence, but now it can survive in the air. If you then think about the cases I said of the SARS-1, that's quite a lot of circumstantial evidence that this is certainly something that occurs. It doesn't have to occur in every situation, but the concept that this disease can be transmitted over longer distances, I think has to be seriously considered.
Robin, we're running a bit short on time, but before we go into the questions, but would you like to, how would you apportion the dangers of aerial stroke airborne transmission against fomite transmission?
Well, interestingly, the fomite transmission, which is one of the definite two mechanisms by which we're told that, sorry, my printer's just started. Sure. Sorry, I just lost my my thread there. So yeah, so fomite transmission. There is really no direct evidence that fomite transmission is important. On the other hand, it seems a really pragmatic sort of argument, but there is no direct evidence. The indirect evidence is that if you drop it onto different surfaces, it survives for quite a long time, and it seems highly likely that someone could then pick it up and transfer it to their mucous membranes. So we don't have evidence, but we think that it seems rational. But I think probably what we have to consider is that different mechanisms will be important in different scenarios. So I sort of have a vision of children in a creche, and I would imagine fomites would be probably a very effective way of transmitting viral particles from one to another. And certainly we know that there are other respiratory diseases where that is very important. And the other advantage of considering that is it's relatively easy to clean surfaces and to wash hands, but there is no direct evidence for that. So now we come down to...
Fascinating, given how much, I mean, I'm just looking at the questions we're getting, how many of the questions actually are around fomite transmission. Charter Erasmus, for instance, says, can one have fomite transmission from supermarket items using, or for instance, using the motor car of an infected person later after they'd driven it? And Dr. Bukalani in Benoni says, his question is broader, but he says, GPs, despite all the precautions they're taking around patient screening, temperature checks, history of exposure, sanitization, mandatory face masks, distancing of seats, all the regular cleaning, and of course cleaning has become a big business thing in the whole COVID pandemic. GPs are still contracting COVID.
Well,
and preventions and precautions.
I think all health health professionals are at high risk of acquiring COVID, and I think really the crisis that's caused by this epidemic or pandemic is the impact on healthcare systems. And certainly I would advocate that if you're in an area where COVID patients are, that you use an N95 mask and that you wash your hands and you clean surfaces regularly. Certainly in my unit, I use hydrogen peroxide to sterilize, because we're dealing with a lot of coughing and sneezing of patients. But I think that we haven't protected the healthcare professionals adequately enough, largely because I think PPE was probably fairly scarce early on. But personally, if I go into an area that I think is contaminated, I would use an N95. We haven't touched on the aerosol generating procedures, which I think is a complete red herring. Again, there was a paper a few years ago looking at all respiratory diseases and their linkage with SARS and others to the so-called procedures. And the only two that really came up were putting a tube into someone's trachea, and the other one was ambu bagging or manually ventilating someone. And it's been a few years since I put a tube into somebody's trachea, but what I do remember is that I put my head right next to their mouth whilst I was looking at their cords in order to push a tube through. The tube pushing through doesn't produce aerosols. What happens is I put my face right in the exhalation pathway of the potential infectious source. Interestingly, other procedures such as which are done at a more remote distance, such as suctioning, etc., were not associated with this. So I think the concept of aerosol generation is wrong. What's happening is your distance and your dilution factor is really very, very small. And I think that's where the high risk is coming from.
We have a question from Graham Menkes. He says, thanks, Robin. Are you aware of research that looks at the ability of SARS-CoV-2 virus to remain viable and infectious within droplet nuclei in the environment? And how harsh is this environment for viral survival, in your opinion?
I think it's an interesting question. I think there's not a lot of data, but the Nebraska study, which just from Santa Pia, that just came out, was the first one that I came across, where they actually infected a cell line from aerosols. I don't think that they looked at the size of the aerosols, but this was from at a distance from patients, so it was suspended in the air. As I said, I think what Graham is alluding to is there's a lot of RNA studies, because that's relatively easy to do. There's not a lot of studies on viability, but there is certainly one. And there are those laboratory ones where they create an artificial aerosol, and those, as we said, can remain viable for up to 16 hours. Probably part of the problem with this is that there's a lot of technical difficulty in measuring particles. As I've intimated, they do change size dependent on humidity and temperature. Certainly what Graham, I think, is alluding to is we don't know what the survival is in these little droplets. It's quite a harsh environment for organisms. I deal with TB, and TB is a very waxy, environmentally tough organism, which of course causes large numbers of cases of disease in this country. These viruses are dependent on the spikes, so we don't know what might affect the spike ability to infect other cells, but certainly it has been shown, and it's technically difficult, but it has been shown to remain viable in a hospital environment and in artificial laboratory environments.
Dr. Ilan Stein asks, given that if we all agree that the spread is by aerosolization, how would the strategy to limit the spread change in a practical manner?
Well, I think that, yes, there's no doubt that distance is still important because of this sort of cube power of the distance. So, you know, if you're 1 meter away, you probably have sort of 4,000 liters, but if you go 2, it becomes 16, and it grows very, very rapidly. So the dilution factor is important. It seems from some of the data that I showed you, some of those cases, that these droplets can be carried on air currents. So it means that you have to consider the direction and the currents. And then the final one is if you have a droplet nuclei which can remain airborne for long periods of time, then you move into the field of air exchanges, per person ventilation, and the whole field of trying to dilute out these or destroying them with ultraviolet or something along those lines. So I think that in different scenarios, we're going to have to consider different modalities of transmission. I think transport is one that particularly worries me. There have been cases of transmission within motor vehicles because of the circuitry of the air passaging. It seems as though in planes it certainly can occur, and one of the strange anomalies is quite often the ventilation comes from above and aimed downwards, and yet the natural way for us to get rid of particles is because of the heat and the temperature is for them to move upwards. So in fact, having downward movement of air could actually make things worse. So my son came back from his Uber driving and was very pleased that the Uber driver had a sunroof. And I congratulated him on that because I thought that was the right direction to take all the particles.
Yes. There's a lovely question, and I've seen the topic discussed extensively on social media from an anonymous attendee who says, what happens during running? How close can or might one be affected if someone runs past you? And they write, I noticed the runner's perfume was instantly smelt as they passed me, and I remained for at least 50 meters. And then let me add a second one, which is also just on the idiosyncratic but interesting side. Do you think different languages might have different levels of projecting airborne particles? This might lead to different levels of transmission according to the predominantly spoken language in a region.
So I'd refer the person to that interesting article from 4 different languages spoken. I think that my feeling is that just the ventilation rate of, say, 5 liters per minute produces the same number of peripherally derived particles. You add to that via speech and by other activities, sneezing and things that come from the upper airways. So it's an interesting concept, but I know that P's and explosive sort of movements of lips and linguals probably produced larger particles, and larger particles are easily stopped, of course, by cloth masks, etc. But coming back to the running, I think essentially I'd come out and say probably 90% of the transmission is taking place indoors. Outdoors, I think it's the dilution factor is so massive that if you're more than a meter away, I think it's highly unlikely. I do my exercise down near the Atlantic coast, and normally the speed of the wind is such that I'm sure the risk is very, very small. I think indoors, close contact, obviously, the further you get away, then you're going to be more interestingly dependent on air currents. And if you have a poorly ventilated area, then you're going to be more dependent, more at risk from little droplet nuclei. Outdoors, generally, I think you're going to have to be pretty close to somebody in order to get around. But again, this is sort of applying common sense rather than hard scientific rigor, because it's difficult to design those experiments.
Elias Shemley asks, what about aerosol generation from a dental headpiece? Could that spread the virus in a dental surgery?
A dental headpiece? I'm not quite sure. What do you think that is? Certainly, dental procedures.
Whizzing machinery.
Yeah, well, I would think that that probably is an aerosol generating procedure. I think that these very high speed drills, etc., probably do create particles on the larger side, being above 10 microns and able to be ballistically sent. So I would think that probably would be a genuine aerosol generating procedure, and common sense would say perhaps they need to have N95 masks while they're working on that. Although larger particles, of course, would be stopped by surgical masks as well.
Yunus Musa asks, can you give some kind of idea of how many viral particles one could expect in a microdroplet and the proportion of particles that would contain a virus? And can one extrapolate from other pathogens? And if aerosol is an important route of spread, would you not expect much higher transmission rates?
Well, on the droplet size, if you have the virus is between 100 and 120 nano meters in size, and we're talking about droplets in microliters. So we've got a factor of 1,000 between there, so a factor of 10. So I did actually at one stage work out how many viruses would fit into a small particle and a large particle. If you get up to 50 microns, then it would not be impossible to get 1 billion viral particles into that size, because you're dealing again with 4/3 pi r cubed, which is the volume of a droplet, and as the diameter goes up, so the potential to carry virus. So then it comes down to what is the infectious dose, and we don't really know. We think that large particles in hitting the mucous membranes and the upper airways can transmit the disease because it's in parallel with influenza and other things. But these small particles, which is what the aerosol scientists are trying to say should be considered, they're in the 1 to 2 micron particles, which will certainly be able to contain hundreds of virions, but they would be delivered directly to the peripheral lung. But we don't know what the infectious dose is.
Asks, what do you think the role of contamination of foodstuffs are in transmission? Speaking of the likes of reports of salmon and meat products as being a potential vector.
So I think that comes from the sort of the meat processing story, and I haven't really had a satisfactory explanation. I'm not very au fait with what happens in these, but it seems as though they're quite noisy environments where there's a lot of immigrant labor in the States being very close to each other in a very cold environment and shouting. And so the question is probably the transmissions from human to human. I don't think there's been any evidence to date of food to human, except for right at the beginning of the Wuhan animal market story. But it seems that there may be other reasons for why the transmission was so efficient in meat processing factories rather than the meat itself.
Robin, Dr. Dave Knight, occupational medicine physician, talks about school policies and saying, where are the high quality cohort studies looking at transmission in schools? He mentions the Australian school study that is so often cited. It doesn't appear to have been peer reviewed, and yet it's very heavily referenced as a reason to open schools. All that he's been able to dig up is a very brief report on a government website with very little detail. You might want to just expand into the general thing of policy making, for instance, on schools and taxis around transmission and the assumptions that are being made.
Yeah, I think we've sort of lost some of the messages that we had historically in schools. I was a schoolboy longer ago than I'd like to admit, but one of the jobs that was given to you each day was the window monitor. And what happened was that they had opening windows high up which could be opened, and those are much more efficient ways of ventilating spaces, because each person is producing a plume of hot air, so the air is being moved up and out of the building. And I think that's something which we've lost. So interesting, I've been hearing of schools where they close those windows and open the low windows, which of course produce air currents which are likely to move particles horizontally, which is what we don't want to do. And then, as I pointed out, in public transport and in planes, the ventilation actually is the opposite way. So there's a lot we could do on ventilation of these spaces, but the problem is that we don't have enough time to do that. Next question is really, how infectious are young people, and at what age are they likely to get disease, or what age are they likely to be able to spread it? And the data there is looking, I think the Icelandic studies have shown that probably the younger children don't seem to be as infectious, but I mean, the data really is pretty thin on the ground for there. As far as taxes are concerned, if I was to try and design something which I thought was the most efficient transmitter of this type of disease, would be a taxi. Their saving grace is that they have very large doors which open at regular intervals, so that does increase the ventilation. And the other one is the exposure time, which is relatively short because of the short distances. But a closed box going to the Eastern Cape and back would be pretty dreadful from my point of view. We have looked at TB transmission risks in public transport, and it's there, but because of the time of exposure and the difficulty in transmitting relatively TB compared to these sort of respiratory viruses, it's probably quite important. I'd like to put sunroof and change the ventilation system and keep the windows open all the time, but in the Cape winter, that's going to be difficult to do. So obviously you can triage people to try and keep the most infectious people out, the ones with temperatures and symptoms. You can try and decrease the air plumes coming out of people with cloth masks, but ventilation is going to be critical, and the number of people in the vehicle is going to be critical as well.
Moses Mkwabe of the Southern African Development Community Parliamentary Forum asks, has there been any investigation on COVID and TB patients, given the prevalence of TB? And is there any further newer research on that also as HIV?
Well, actually, there's some quite nice work that was done by Marianne Davis in the Public Health Department in the Western Cape, in UCT at the Western Cape, looking at patients admitted and sick with COVID. And they managed to come up with hazard ratios associated with different diseases. And certainly they showed that diabetes was strongly associated, and the severity of the glucose intolerance seemed to be related to that. TB, they showed that current TB had a relative risk, I think, of around about 2. Prior TB was much lower and I don't think reached statistical significance. HIV came out at about a hazard ratio of 2-fold, but it was a little bit bizarre as far as treatment was concerned. It didn't really fit. And the problem with these retrospective studies is there may be other co-founders or confounders. So, you know, it may be, for instance, that people with HIV are more likely to come from a certain area or a certain economic group or certain behavior patterns. So attributing it all to the disease that you're looking at is always problematic. It's nice to see a graded response, and I think I'm much more convinced by the glucose intolerance, the diabetes. The TB seems rational, that if you had TB years ago, it's not as much of a risk factor as if you got it now. So that's a sort of graded response. The graded response for HIV wasn't there, but certainly it seemed as though there was a relatively mild increased risk associated with HIV, but it didn't quite fit so well with the treatment and the well viral suppression component. So raised the possibility that there may be some confounders.
Leonard Heidenreich asks, a study by Jones et al. At the Institute of Virology in Berlin shows that the viral load of SARS-CoV-2 in children and adults are the same. Can we assume from that that children are just as infected as adults with COVID?
So one of the things I didn't mention to you is that if I look at the particle production from individuals, it's very consistent within the individual. So if I looked at you today, William, and I looked at you tomorrow, I would get the same results. But if we compared my results with your results, they could be incredibly different. So it does seem as though there's a lot of variability, and certainly raises the possibility that these super spreaders may be people who produce many more particles than others. I don't know, but it's certainly a potential. It's related to the respiratory volumes involved, and children have smaller volumes. So it's interesting. What they're saying is the amount of virus in the upper respiratory tract secretions are equally high, but it doesn't really prove one way or another what happens in the real world. And that will be related to the size of their lungs, their behavior, whether they cough and sneeze more than adults. But I agree that the data is still open.
This one is, it's an anonymous question about your comment on the studies carried out by Aalto University. I'm not sure which study this is. You probably know. It might be the one on researchers modeling the spread of the coronavirus, emphasizing the importance of avoiding busy indoor spaces. I'm not sure if that's the one that he's referring to. He or she is referring to.
What is the question?
What is your comment on the studies carried out by Aalto University?
I'm not aware of those. It's not in my list of.
Okay.
Obviously, tend to go by authors rather than necessarily knowing what their affiliation is. Sometimes I know what the affiliation is, but
this is a project. I think he's referring to a project carried out by a Finnish research organization, which studied the transport and spread of coronavirus through the air.
And what was their conclusion?
Avoid busy indoor spaces.
I think that sounds very sensible advice. Personally, if I go into somewhere that I think is poorly ventilated and is a risk, I wear an N95 mask because I'm at a high risk group. So I would follow their advice. I don't like poorly ventilated. And part of the reason for that is that I do actually live in the city that has more TB than the whole of the United States of America and Europe put together. And the risk to my life of acquiring TB is much higher than this. It's a 4% mortality rate for normal TB, let alone MDR TB. So we live in an environment where ventilation should be taken more seriously.
Robin, we only have a couple of minutes left. I was wondering, given the implications of this research, what should South Africa be doing in terms of its policy determinations, which has been jumping every which way? Taxis are now allowed to load fully. Schools, despite the research that suggests they shouldn't be, and schools are no longer going back, the public schools, although research suggests it would be perfectly safe for them to do so. How do you see the policy unrolling or unraveling in South Africa?
So I think we touched on it last week, is what is the exit strategy for all this? Are we going to try and stop transmission by social distancing indefinitely? Are we going to do it for a period of time until we get a vaccine? Will the vaccine, that seems a hope, but not necessarily going to happen. Will we be trying to protect the individuals at risk with passive immunity, which I think would be a very nice solution? So you'd watch the epidemic, and then as another peak started developing, you would protect the vulnerable population around there with a relatively short-lived policy. But I think the key to this epidemic or pandemic has been the impact on the westernized style of hospitalization. That the big fear has been overwhelming of health systems and health facilities. And I really think that when I look at the infection rates of young doctors in London teaching hospitals, that we haven't protected them adequately. And I think that the rationale for not giving them N95 masks was purely economic and purely short supply in the early days. It wasn't the right thing to do. It was the pragmatic thing to do. I think healthcare workers need to be protected because it seems as though that's one of the special things about this pandemic that is destructive. And that's really what all this talk about flattening the curve was, in order to protect the health systems from being overwhelmed. So protecting healthcare workers would be one of my priorities.
That's a rather chilling and depressing note to end on. Thank you very much, and I look forward to the fourth in the series of PPS. Again, may I invite you, as soon as the webinar is open for registration, to send questions. It helps us a great deal to be able to pull them all together, that rather than trying to get through 20 or 30 or 40 or 60 in a single session, which is of course absolutely impossible. Thank you again very much, Robin.
Thank you, William.